first one here, if the limit is x approaches 3 of h of x equals 7, evaluate the limit as x approaches 3 of 4 times h of x. So this is the first property. This 4 that's inside here jumps out to the front. So 4 times the limit as x approaches 3 of h of x. So all we need to do here, we know this. We know the limit is x approaches 3 of h of x because we're told so right up here. And this just becomes 4 times our limit is 7, which is 28. This one here, if the limit is x approaches 2 of f of x equals 4 and the limit as x approaches 2 of g of x equals 7, evaluate the limit as x approaches 2 of f of x plus g of x. So we don't know what the functions are. We can't add them together right inside those brackets there. So we're going to separate this into two separate limit problems. The limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. And we know each of these. We know from our problem here the limit as x approaches 2 of f of x is going to be 4. We know the limit as x approaches 2 of g of x is going to be 7. So we really have 4 plus 7, and that's 11. This one is exactly like the other one. We've even got the same functions here. So the limit is x approaches 2 of g of x minus f of x. So we're going to separate this just like we did before. We have the limit as x approaches 2 of g of x minus the limit as x approaches 2 of f of x. We know the limit as x approaches 2 of g of x is 7. We know the limit as x approaches 2 of f of x is 4. So we have 7 minus 4, and that's 3. Alright, we're going to do some new functions here. If the limit is k approaches 3 of c of k equals 2, and the limit is k approaches 3 of d of k equals 8, evaluate the limit as k approaches 3 of c of k times d of k. So this is going to be the same as the other two, really. We use multiplication, but we're just going to separate this. So we get the limit as k approaches 3 of c of k times the limit as k approaches 3 of d of k. And we know this is 2 times 8, because we know this limit is 2, we know this limit is 8, so we were told so in the problem, and our answer here is just 16. And the last one of these 4 operation ones, addition, subtraction, multiplication, and now division. If the limit is x approaches 4 of f of x equals 9, and the limit is x approaches 4 of g of x equals 13, evaluate the limit as x approaches 4 of f of x divided by g of x. So this is the same sort of thing. This is going to be the limit as x approaches 4 of f of x over the limit as x approaches 4 of g of x, provided that this denominator does not equal 0. Obviously, you can't divide by 0. Nothing works if you do that. And it doesn't equal 0, so we're good. So our numerator here, the limit is x approaches 4 of f of x. We know that's 9, given the problem. Over the limit is x approaches 4 of g of x. It's also given the problem is 13, and our answer here is just 9/13. And the last property here, kind of the weirder one, but that's all right. If the limit is x approaches 0 of f of x equals 6, evaluate the limit is x approaches 0 of f of x squared. So we don't know what f of x squared is, but we know the limit as x approaches 0 of f of x is 6. So what we can do here is our exponent jumps out and kind of just envelopes the entire limit. So this lets us evaluate the limit inside first. And we know this limit is 6, so this is just 6 squared, which is just 36.